Episode 1, it's June the 10th. Well, I didn't expect to do this so late. I was stuck, royally stuck today. So I was trying to write unit test for React Native app. It was something that's been delayed for more than a year on that project. So, I just started doing it, right? And I didn't think too much about it. I've been doing the tests in the past, and I thought everything would be fine. But over the past year, the app has grown and evolved tremendously with lots and lots of things added. And I had to first decide on what type of unit test I want to do because the app has so many dependencies on the outside, right? It have Firebase dependencies. It has the maps, React Native maps dependencies. All of these things were not there when I first wrote the test more than a year ago. And then, because we wanted to add all these things and test becomes something that's blocking us, so we just deleted it. And now we're in the place where we have to add tests. There's no way the app can keep going on without testing. So like, okay, I need to do the test again. But just looking at this, all those things, if I mock all of them, what's the point of unit testing? So I gave it some thought and finally decided, yeah, this is still value. Unit test is still value, even though I cannot make, and I don't want to make any communication with all the third-party outside modules. It is still tremendous value in the unit test itself. And of course, the ideal of unit testing this app is changed, evolved as also, in my opinion. In the past, we were very much locked in on how the rendering will look like, and not so much of a user-oriented point of view. And that turns out to be bad because implementation changes, details change. You think of something else, you want to add something or change something, and then your test has to change. But now the idea is different. We are testing the logics, right? I mean, the logic doesn't change, like the flow of how you initialize the app. Like when do you load the data? When do you check if the user has logged in? And if the data is loaded, where you go? If the user logged in, where you go? If they are not loaded, where you go? So all of these things are the logics, and they can be tested, and they should be tested. They will not change. The implementation itself might change. I mean, still will test some of the implementation, just like how the user will interact, right? When the user sees something, how they interact something, we will test that, and then the testing lab definitely helps us achieve this. So yeah, this is like the current idea of how to do unit testing. I'm just gonna mock everything Firebase related, mock everything that the map related. Actually, I don't know about the map because the map, yeah, I should mock everything the map related. And luckily, because we use the context to handle, like when we pull the data, into the context. So as long as I have the context, I can mock the context to put whatever data I want inside the context, and then I can mock. I can have the app go on whatever screen I want. So that's definitely good. But that's not the end. This is just unit testing. We also need to do end-to-end testing. So we probably have to use detox. And to use that, we will have to really set up our test environment correctly on the Firebase specifically. So there's a lot to do in this thing, and I thought like 2 weeks might be enough to handle all the testing. No, it's not. It's gonna be much longer. And I don't have much time. Every week I can get maybe like 5 or 6 hours. I want to get more, but every day after work it's a drag. It's really a drag to get into. Take some time to get in the flow, and then yeah, it's tough. Now it's like kind of grinding. I started grinding again in this. And what's more, like I said, I got really stuck today is because the behavior of the fake timer ingest is strange, and I put a question on Stack Overflow that when you call just dot use fake timers, when you do that inside before each, the behavior is different when you call it outside. And the expected behavior happens when you call it outside. But from all the documentation I've read, you're supposed to call it inside before each. So this is just so troubling. I posted a question on Stack Overflow. Hopefully somebody has encountered this and then find it interesting to solve it for me. All right, so it's kind of late. We'll have to not do the count intervals. We'll just finish this and then call it a day. Binary tree. I think I've done this before. It's 199. Yeah, I've definitely done it before. A right side view. Given the root of a binary tree, imagine. Oh, hold on. Are we shifting gears? Last week was all DP. Is this week going to be binary tree? So given the root, imagine yourself standing on the right side. Return the values of the node you can see ordered from top to. Hey, that's a good question. Very good. So the rightmost nodes. So what do we do? BFS. BFS just return the last node. Yeah, BFS return the last node. Oh, maybe I'll finish this fast enough so I can still work on the other problem a little bit. But I don't want to because you know what? I haven't even eaten yet. I'm really hungry right now. Man. Sometimes you just wish that the day can last for longer. But it doesn't happen that way. Oh, shoot. I see the previous result. It's okay. It's okay. We know how to solve this. This is not difficult. I know we don't need the test case. Okay, so BFS, we're gonna have Q, root, and then while Q. That's my way of doing BFS. Temp, and then for node in Q, if node.left, temp.append, node.left, if node.right, temp.append, right. Okay. Oh, I know we need a result, right? Rest equals this, and then once we're done, the last node, so rest.append node, last node dot value, blah blah, return rest. Ooh, my bad. Root dot val, and I'm pretty sure root can be none. Node dot value, yeah. So we have to do if not root, return this. Okay, that's looks promising. Let's run all the test cases. Did I not run all the test cases last time, causing this to be wrong? Oh shoot, I forgot to replace. My bad. Q equals temp. Wait, this doesn't time out? Yes, there we go. Oh, what the hell? What did I return? One. Because I do the first one already. Yep, it shall be right. All right, that's correct. I mean, the challenge is if you want to do DFS. Why you want to do DFS on this? I don't understand. No, I'm not. I think I'm just gonna end here and then see what type of method I used in the past. So this is a straightforward BFS. I mean, normally, I think any problem that can be solved by BFS shall be able to solved by DFS as well. Oh, I know. If a node does not, oh, hold on. I was going to say if it doesn't have a right children. This doesn't have a right child. Oh, we go on the right. Oh. Yeah, and if we, all we need to do is just keep going on the right. Okay, let's try this. So we're gonna try DFS, right? So we keep going on the right. The rest equals this, def DFS, a node, optional, tree node. And we don't return anything. Don't have to return anything. If node, right? Res.append node.val, okay? And we say if node.write DFS node.write, else DFS node.left. So we always try to go to the right, and otherwise we go to the left. And then we'll call DFS root, and then return res. You know what? This is actually faster. This is like OH. Well, of course, I have to make sure this one's correct. Yeah, this is faster. Oh, shoot. Is that the same error I had in the past? 1, 2, 3, 4. Tree visualize. I don't think. Oh, wow. That was good. That was good. 1, 2. Oh, shoot. Damn. Interesting. How are you going to solve in DFS? Yeah, we go right. And I say if it's no right, we go left. If there's no left, we return. We try to go here, and then we have to, yeah, we have to count, right, on the levels. You know, in that case, why even do? Let's see. Is this BFS? Yeah, it's also BFS. I think I probably have more test cases this time. 211, 215. So DFS doesn't work. I mean, it works, but just not. Let's see. How would you do DFS? You have to keep track of. Yeah, you have to keep track of the depth. Okay. Let's still try. Yeah, this is not right. You have to keep track of the level. You have to keep track of the level. And how do you track the level? So how do you track the level? So you go down a level. So every time you go down a new level, if we go left, root, and right, left, root, right, and then each time I get to a value, Yeah, if I go left, right, so it's not gonna be. We say level is 0, right? Level 0. If no, we say if len res is smaller than is equal to level, res dot append no dot val, right? And then else res no level equals no dot val. We're gonna go left first. So dfs no dot left level +1, and then do this, and then dfs no dot right level +1. So I'm gonna have level 0. All right, let's try this one. Basically, what I'm trying to do is always add new value each time, but the later encounters will override the previous encounters. And we need to do 1, 2, 3, 4. Okay, let's see. Index out of range. What? Which one? Oh. I have to. I'll change it. Do this first. Do this first. I'll do these later. There we go. Yep. Whew. It runs faster. Nah, this is over. This is nothing here. Okay. Do we want to keep going? No. I want to stop here and just call it. I mean, I won't be able to solve that problem anyway, and I'm really hungry. So I'm gonna take an easy way out today, and I will see you guys tomorrow. Adios.